Hope you're in the right place. We're going to do a workshop on data cleaning and visualization in R. Is everyone able to hear me correctly? Is my audio coming through well? Yep, thumbs up. Okay, great. We'll wait just a minute or two to see if we have other participants coming in at the last minute. I'll go ahead and share my screen so we all know we're in the right place. Okay. Assume that if you want to be here, you are here. Go ahead and get started a bit. This workshop is targeted for people who basically who haven't used much R before or are using R for only basic purposes, and it's to show you how to use it for a specific purpose. It's not going to be a general R course or a general R workshop. It's specifically teaching you some functions and use cases for how to clean a data set if you've gotten data from somewhere. It's not in a good format for analysis. You don't know what to do with it. It has lots of holes in the data. We're going to look at some different functions and techniques to get it into a useful shape. So we'll just go a little bit over that. I'm using RStudio. You don't have to use RStudio if you have another program like Jupyter notebooks or other notebooks. Use that instead. RStudio is free. If you don't have it, if you don't have something to run R in already, you can download and install it pretty quickly. You want to go to r-project.org. It's going to redirect you to a different site. It's changed since I wrote this. But you can download that. Sorry, our project hasn't changed. RStudio has changed. But you download both of these. You install R first and then RStudio. Is there anyone who does not have R installed at all and needs a couple of minutes to get that going? No, everyone's pretty much here because you have R and you need to see how to use it. Okay. If you're coming in later, you're watching this on later, you can go ahead and time to download and install it. I'm sorry, and I also forgot to introduce myself. My name is Scott Malden. I'm Data and Visualization Services Librarian, and this is actually going to be my last workshop because for a combination of reasons, I'm coming back to China next week, and I'm going to be basically in childcare mode. So I'm not going to be. I'll be ending my my employment with DKU starting next week. So yeah, time to go out with a bang. Unfortunately, it's not a bang because this is not the most interesting workshop. It's less. It's not the most engaging. It's more utilitarian. So let's sort of jump to it. You can either, let me give you the link that you will need to do this. No. So we can look at that. Okay. Let me send you this link. Okay. Let me send to you in the chat box the link to download the files we will be using for this. You have a choice in whether you want to try to follow along with a blank notebook in our studio, or if you want to download the pre-made code. I think if it's going to be tidying the weather.rmd and just follow along with what I'm doing. In any case, you'll need to download weather.rds, and then you can download, if you want to, tidying the weather.rmd. We'll download those both to the same location. And then I'm going to show you with the code that I've already written and sort of walk you through each of the things we're doing to clean up the data. So if you are completely in RStudio, you've never used RStudio before, you can go to File, open up RStudio, and you can go to New File. I like to do an R notebook. New File, R notebook. In an R notebook, if you've never used one before, you have what are called chunks, and that is you can make discrete units of data that you can run separately instead of having to do it all in the console where everything just runs as you type it. So this is the format for creating a chunk. You can either sort of copy this and it will automatically create a new chunk with functionality here. Go up to the top where there's this little C for chunk, and you can select the type of chunk you want to. The great thing about R notebooks is that you can insert bits of code from other programming languages, not just R. If you're doing more advanced projects that require different functionalities from different programming languages. Today we're going to be working just in R. If you want, you can start with a blank notebook or an empty notebook like this. You can delete everything except the chunks if you want to. Or you can open the file, navigate maybe in your downloads or wherever you downloaded those files to tidying the weather.rmd. And if you do that, you will see this, which is the code we're going to need to clean this data set. I was already practicing here, so I'm going to clear everything. So this is what you should see if you open it up in RStudio. The first thing we're going to need to do, if we haven't done it already, is set our working directory. If your data file, what was the name of it? If your weather.rds is already in the same folder as your project, you won't need to do this. If it's not, then you'll need to set your working directory to tell R where that data file is. And we do this with the setwd command. And then you'll need to put in the directory, sort of navigate in your browser, or navigate in your navigate on your computer in your Explorer to where the file is, and you can copy that and paste it. And then you will need to actually invert all of the slashes, because Windows uses backslashes, but R requires forward slashes, so you'll need to convert all the slashes. I'm not sure it is on a Mac, so apologies for that. And then we're going to import our data. So we're going to read an RDS file. If it's in a CSV format, it's the same, but you're going to use this read command. Read, and then the name of the file, weather.rds, in quotes. And we're going to assign that to a name, to a data set here, so that we can access it in R. Then we can look at it by hitting weather. So this is the code for the chunk, and we can press this little play button to run the chunk, and it runs all of this data here. So we can see what our data looks like. This is a data set for several years ago now. And it's structured in a way that is not very useful to us. It's structured in a wide format, in a way that's really not what we would call a tidy data structure. And we're going to look about how to put it into tidy format. I'll come over here and give you sort of the definition of tidy data. Tidy data can be error-free and concise, but still be poorly organized for data analysis. Tidy data has one observation per row, and each column is a unique variable. So there are a lot of ways in which the data that we have here, this structure, is not what we need. This data, what we have here, is what's called a wide format. This is a format you often see some international organizations publish data in this format. It's often used in Excel. If you're doing Excel-based data analysis, you might see a lot more things in wide format. But that's not the standard for data analysis. And the difference is this. Untidy wide data, you have one of your variables, for in this case year, stretched across as separate columns. And that can be useful for sort of intuitively understanding the data. You can sort of visualize in your head. It's sort of like each row is a chart. You can sort of see how one of the variables you're looking at changes over time, for example. However, that's not the most useful for data analysis. So we need to put it in what is called long format, in which every variable is a unique column. It is a single column and not stretched across columns. So we need to get it into this format. So that's going to be our first step in tidying our data. We're going to use the library called tidyverse. If you've never used tidyverse, you'll need to install the package here. In RStudio, you can go down to the bottom right under packages and click install, and you can just search here tidyverse and install. It'll take just a few seconds to do that. And once that is installed, you can type here library tidyverse, and we will run that to load the tidyverse package. And tidyverse is a very common and standard data analysis package. It is used for helping to create tidy data. And you might see a few conflicts. Normally, it doesn't pose a problem. So moving on, we're going to, if you've never used the head command allows you to just view what is the head or the first 10 rows of your data, or actually 6 here. Sorry, the first 6 rows of your data to sort of just glimpse the structure and what sort of variables you're working with. So we can look at head, see how everything is. And you'll notice in this that we have this sort of initial column where every row gets a number. That is something that's unnecessary. Since we're going to completely structure the data, we're going to get rid of that column. In tidyverse, using tidyverse syntax, we can remove a column with this syntax. You can call the data set you're interested in, and then in brackets, if you put a -1, normally this is before the comment is rows, and after the comment is columns. And we're going to remove with a negative sign this first column. So our weather 1, we're going to, I'm going to, you don't have to do this, but for purposes of keeping track of what we're doing, every time I make a big change to the data set, I'm going to give it a new number so we can look back and see how our data set has changed over the course of this analysis. So weather 1, so it's just the same thing, but going from version 0 to version 1. We're going to remove that first column. And so we can view the head again. And we can see that this is before, where we have this extra column with just the row numbers. And this is after, where we have removed that. forgot to say, if there are any questions at any point, feel free to stop me. So the next thing we're going to do is, as I mentioned, we're going to actually get it in, try to get it into tidy format. There are two processes. When it's wide and we go to long, we call that gathering. And when we're going from long and putting it in wide format, we call that spreading. So generally, what we're going to want to gather wide data. However, there are some instances where we're going to need to do it in the opposite direction and to just sort of see what that looks like, how it transforms the data. Basically, it's like this. It's almost like you're taking the number of rows and taking the number of columns and multiplying the number of rows. You're moving it into that format. You see that you sometimes get doubled. You get basically a double number of rows because you're converting columns into rows, and you can very quickly get very, very long data with taking something that at the base has only a few hundred rows and turn that into something with thousands and thousands of rows because you're multiplying. So what we're going to do is we're going to gather this data. And the format of this is we're going to, in the gather function, the first one, we cite the data set we're interested in. And then we're going to each of the columns into a column that we're going to call day. Because each of these, if we look at all the data, we can see that actually it only goes up to 31. Some of them, because they're not months, at 31, and so we can see that there's a month here. So the way that the structures, we have year and month, and then for each month we have the days spread out as separate columns. So what we want to do is group those all together into one column of day. And we want to put the values in that place. Sometimes you might want to do a count instead of values. In this case, we're putting the values. So 1 is going to 1, 2 is going to be stored as 2, etc. And then we want to put the rows that we're in, the columns that we're interested in. So in this case, x1 and then colon x31 are the names of the columns we're interested in. And then it asks us if we want to rename, rename our NAs, what we want to do with our NAs. Oh, sorry, to remove. Do we want to remove our NAs? Yes, we want to remove our NAs. And that's going to give us the resulting data set. We're going to gather all that together. It's going to give us this data set. So if you want to compare here, whether one looks like this, and then once we've done that, the result looks like this. It's very concise. Now we can't scroll down. That's the only columns we have. All of our days have been turned into that. And so now we actually do want to do a bit of spreading, because if you remember from the definition of tidy data, has one observation per row and each column is a unique variable. So each column is a unique variable. In this case, in our data, each column is not a unique variable. We have this one column that has all of our measures that we are interested in for looking at weather, so temperature, precipitation, etc. That's all in our measure column. Spread that measure column out to make sure that each of those separate variables has its own column. So in this case, syntax is much simpler because we're just going to say we want to spread from this data set, spread out measure, and in the resulting cells we want to put the appropriate value, the value of each cell. And so we run that, and the result is this. Now all of our measures, each of our measures, dew point, humidity, etc., has its own column. So we're approaching tidy data. Next, what we want to do is group all of our year, month, and day into one date that we can work with. That way we can do analyses based on the date. So we're going to create a new, sorry, we could have done this afterwards, but create a new instance of the data set, call it weather 4. And on day, we're going to replace all of these X's with nothing. We're going to get rid of all of these X's in the day column. So we just have the number left. So it's going to say in our weather data set, the column day, we're going to replace all instances of X with nothing. So to make it blank. Then we can see that that works correctly. And now we are going to bring our three date columns together. So with this, we use the unite command. So in unite, it's going to ask column is equal to date. We're going to call the column date. And it's going to ask for which columns we want to unite together. So year, month, day. And then we want to put any sort of separation between the values. We're going to put a dash. So we're going to get a dash format. It's going to be year dash month dash day. So pretty standard. So that's the unite function. Okay, and you can see that RStudio will tell us what format each of these columns is. And all of our columns are being encoded as characters, which is not what we want. We want them to be encoded as dates or as integers or doubles, as the case may be. So we want to tell R to change the format of our data. First, we're going to start with the date and say that this is going to be stored as date. So I'm going to make a new version, weather 6. And in that weather 6 date column, we're going to put the weather 6, sorry, we're going to put the date column again, but as date. And that's as format date is the function to convert something that's not stored as a date to a date. And we can see that it now tells us that it's stored as a date, which is what we want. And the next thing we want to do is to pull all of our columns into a different format. We'll pull them into a different order. Basically, what we want to do is take our events column, which is where we record whether there's rain, whether there's snow, etc., and put it ahead. Because the reason for this is that our events column is stored as characters and should be characters because it's something like rain or string. And the rest is all numerical format. And so if we want to do a mass conversion on all of our data, tell all of our, say that all of these rows should be numerical data and not stored as characters, if we move this cloud cover column over, if we basically switch these two, then we can have all of our characters together, which is just one column, and all of our numerical data together, which is another column. So we're going to tell select function, we can reorganize the data. Take our data set, we tell it basically the order in which we want all of our columns. So we want date first, then events, and then all of our other columns, cloud cover through wind degrees. And then you have to manually scroll through to see what the last one is. So everything from cloud cover to wind degrees, we put last. And we can see that the result is what we want. We have date here, then events, then all of our other columns at the end. We have a few more bits of data cleaning we have to do before we can convert to numerical data format. And the result is that the reason for that is that in our data set, we have some examples of untidy data. If we look up here, for example, we can see that we have some things that are trying to find examples here of where we have unclean data. Um, I can't find them. Oh, okay, so here, for example, we can see that we have examples like precipitation inches, we have T's in the place of our data. So this is just an example of, of sometimes you might have something that was entered by the person who's entering the data. They have their own personal sort of code for what their data means, but they don't pass on what that means to the person who's analyzing and working with the data. So in various areas, we might have different data that is recorded with with code we don't understand, or things that should be numerical that are not recorded as numerical. And so we need to remove those and convert them to numbers. So for example, we're not entirely sure what it's supposed to be, and we could just eliminate that data entirely. We could eliminate those rows since we don't have incomplete data, or we can do something like convert it to a zero. And so either way, whichever we want to do, we can do string replace. This function string replace is going to ask us, okay, which data are we going to replace? We're going to do weather 8, and in the precipitation inches column, we want to replace all those T's with zeros. So string replace is going to replace all of those. It's going to show us the result. We can see that there are no more T's. They're all zeros. So we've replaced all of our characters with numbers. All of our data is now in numeric format. We don't see T's or anything else in any of the other columns, just in precipitation inches. So what we can do now is tell R to convert everything into numeric. So we're going to make a new version of weather 9. We're going to mutate at. That we're going to mutate, we're going to change our data structure. Data set. We'll do it with these variables. Cloud cover, 1 degrees. And this is what we want to do. We want to apply the as numeric function to all of these rows. Remember, up here we did as text, as date. It's the as date function. It's basically the same format. We could do as numeric and then do each column as we wanted, or we can do the mutate. The point of this code is to give you ideas of different ways of structuring your data, and potentially different functions that you can use to accomplish the same thing, so that you can be flexible when you're doing your own data cleaning and analysis. So for mutate, we apply as numeric to all of these columns, and we can see that it now gives us the result. Everything is converted to numeric as it should be, except for the events, which are character, and the date, of course, which remains as a date. So now we can view, we have everything clean and tidy and in the right format. However, now we need to work at finding and replacing errors. And this is the most tedious part of the data cleaning, is finding and replacing errors, because errors could be in many different formats, could come in many different shapes and sizes, and we may not always have all of the data that we need to fix the errors. So let's look at a summary of weather and see where some things might stick out. And in order to highlight, I'll go over here to the PowerPoint so we can see more easily. Sorry. here's the results of the summary. Oh, yeah. See, there are some things that stick out. First of all, gust speed, you have NAs, which we need to get rid of. Max humidity, you have something that's 1,000. And visibility, you have a negative. And so how do we know that these are errors? One possibility is that you can't. If it's weather, since we're working with weather data, it's something that we might be able to intuitively understand. We might know that humidity can't go above 100%, that visibility can't be negative. But I want to talk about an important principle that you can't fix errors with data science alone. You have to have either some knowledge about the subject. So in this case, we might know some general knowledge about weather and how it works. Or you simply, specific knowledge about the study that you're looking at that allows you to know its limitations and what sort of things might have been recorded as errors. Or you have to have, another thing is you can have a collaborative relationship with the researchers who did the data collection to ask them questions. So only by having one of those things can you sort of know which data is erroneous and what needs to be corrected. You don't necessarily know that 1,000 is an error in terms of humidity unless you know something about how humidity works. You can't data science your way to knowing what is an error and what is not. So let's take a look at how to fix those. So I have two different ways of doing this here: a hastily cleaned way and a cleaner way, cleaned way. I'll sort of go through the hasty way to just show you how we might do this if we're. I mean, this is not good. Not a good example, but just to show you examples of what we might do. Don't do this on your own. Take the time to do it the cleaner way. But if you're in a hurry or something, you're 10 minutes before your report deadline is due, is something like this. We can replace all of the NAs in the max gust speed with 0. So we find our max gust speed column, and we replace the NAs using this. We say replace all of the NAs in our max gust speed column. Basically, it's saying we're going to take the replace NA function. We're going to run it on our weather max gust speed column, and we're going to copy the result or replace the result, place the result into the same column. And so wherever there's an NA, it replaces it with 0. That's the structure of this replace NA function. Wherever it finds an NA, it's going to replace it with 0. We're going to set all of the 1,000s in humidity. We're going to assume that maybe there was an error and it's supposed to be 100 instead. So here it's different format. You can instead of replace NAs, we're going to just we're going to tell it everywhere in weather humidity where humidity is equal to 1,000. So we're going to call the column, and then we're going to say whichever entries on the column where the value is equal to 1,000, we're going to replace it with 100. We're going to set then all of the. So this is a typo here. My apologies. Visibility, we have those -1s. We're going to place them with a sort of intermediate value, which is 5. Why do we do that? It's sort of an average of what's in visibility. There's all those -1s with 5. And then everywhere where we have on events, if you remember from up here on events, some things are blanks. In general, we should avoid blanks. So we want to put it with something that shows to someone else who's looking at the data that that's not a blank because we forgot to put data there. That's a blank because there actually is nothing to put there. And so we can put something like no precip. So let's get this is the same structure as this one. We call the column, and we say everywhere in the column where the value is equal to nothing. We're going to put no precipitation instead. So this is the result. We have replaced, we've fixed all of those errors. So max humidity, the max is no longer 1,000. We no longer have the NAs. We no longer have the -1. So this was a quick way to repair those. If we want to be more clever, we can get a bit more complicated. And this we're doing sort of a search and lookup function here. So instead of replacing the max gust speed with 0, we can replace it with the max wind speed instead. So I'm not a I'm forgetting the term now. I'm not a meteorologist. I am not sure of the technical definition of the difference between gust speed and wind speed. As far as I know, I think wind speed is something more constant and gust speed is a sudden burst of wind. So we're going to assume that whatever the max wind speed is, we're going to replace that with gust speed because perhaps they are correlated in some way. To do this is complicated. We have to generate an array of the row numbers where the max gust speed is NA. And then on those, wherever that corresponds, wherever that is true, then we set those entries equal to the max. So then we set the max gust speed entries equal to the same values for the max wind speed column. So it's a bit complicated if you don't do too much in programming how we do this. But basically, we're going to make a variable called max gust index. It's just going to be a series of true false, whether something is NA or not, and it's going to look like this. So wherever the max gust speed column is true, basically we're going to have a true, and wherever max gust speed is not an NA, it's going to be false. And so we're going to have a string of true false. We can look at it over here once we've run it. Max gust index. Sorry, 1 second. Oh, my mistake. It's not, I was thinking of a different format. It's not giving us true false, it's returning the row numbers. Sorry. It's returning the row numbers 161, 205, 273, 275, 308, 358. It's going to return the row numbers where that is true. And then what we're going to do is going to say to copy the values from max wind speed that correspond to those row numbers. So we're saying max wind speed of those row numbers, so that in the max wind speed in the max wind speed column, rows 161, 205, etc., we're going to copy those to max gust speed, 161, 205, 273, etc. So the result is that we're identifying which rows we need to copy and copying those to the same rows. So the humidity replacement, what we did up above, even though it was quick, it was probably the best thing we can do given the circumstances. As 1,000, we can assume maybe that was a typographical error. Someone meant to type 100. They wrote 1,000 instead, so we could just replace those like we did before. And then mean visibility, we're going to do the exact same thing that we did with gust speed, except we're going to basically identify, instead of setting up a separate index, we can just do it in the function where we ask it to do what it's doing. So, sorry, it's been a while since I wrote this. Yeah, so we get this index where where mean visibility is equal to -1, and we replace it. Right, so what I decided to do in this case was to find the arithmetic mean of the min and the max, and to replace negative ones with a mean value, with an average value. So everywhere there was a negative one, I put sort of an average value of that entire column. So I did the max plus the min divided by 2. So we have mean visibility. So instead of we have 3 separate columns: max visibility, mean visibility, and minimum visibility. And so it seems safe to assume that the mean visibility should be somewhere between the max and the minimum. So what we did is an arithmetic mean everywhere. For each day, we're going to find the max and the min, add them, divide them by 2, and set that equal to the mean. Hopefully that should give us something that is reasonable. And so we can see that this is another way we do, though. Our errors have gone away. Right. So we now have, after much ado, we now have taken our dirty data and we have cleaned it. So we can now move on to visualizing our data. And so the cleaning part is tedious. The visualization part is where we can start to have a bit of fun. If you've never used ggplot before, ggplot, the GG stands for Grammar of Graphics. It is a very versatile and detailed way of doing visualizations in R. There are built-in visualization functions in R, but they are not as good, and they are not as detailed, and they're not as easy to use. And so ggplot is a very standard, common way of doing visualizations in R. Let me find, I have a cheat sheet, ggplot2 cheat sheet, to sort of show you how data visualization in ggplot works. And basically it works by building up discrete units. Let me see if I can zoom in. Sorry. So it's based on the grammar of graphics, the idea that you can build every graph with the same components, which is basically your data, your geometries, your visual marks, and the coordinate system. And so the way it works is this. Sorry, it might be a bit hard for you to see. Let me zoom in more. Everything is built with discrete chunks. You initiate your ggplot function, you declare which data, and then you add layers of visualization. And so you can have, based on the type of charts you're working with, you have different charts you can use, and you can then add things on top of them. Let's look at a few examples to see how we do that. So the first one here, we're going to do a dot plot. We're going to take our cleaned data, and we're going to look at, this is declaring the aesthetic functions. We're going to say that X is our minimum temperature. Our Y is going to be our max dew point. And we can add a lot of diversity to it. We can say that the color of the dot is going to be equal to the type of event. So like whether it's raining or snowing, etc. And the size of the dot is going to be equal to the amount of precipitation. We're going to tell it the type of visualization we want, so point. And we also want to add a line. We're going to see why we do that. The intercept is going to be at minimum temperature equals 0. And so it's going to be at the 0 point. And so this is the visualization that generates. It's not bad. It's pretty visually interesting, and it communicates pretty clearly the data, I think. And so this is a chart of max dew point over minimum temperature. And so the idea is that dew point represents the temperature below which water starts to condense from the atmosphere. And the idea is that you get precipitation more when the temperature falls below the dew point. And so this line we can add is saying that under this line, our dew point, or sorry, our temperature does not fall below the dew point. And on this side, the temperature does fall below the dew point. And so we can see that as maybe we can start doing hypothesis testing about the way that precipitation works. We can see that it seems generally true that precipitation occurs only or almost entirely only when the temperature drops below the dew point. So by adding this line, we can start doing hypothesis testing. And we can, if we want, we can just take out this line. That's the thing about ggplot is everything is discrete, so you can remove or add whatever you want. Oops. I undid. So we can add it back in. Like I said, we can easily add more units, so we can do the same thing, and we can add x-intercept of 32. So 32 is the freezing point in Fahrenheit. So we can see that almost only to the left of the freezing point do we see snow events. That snow generally occurs. There's one where it got a little bit warmer, it still snowed, maybe it was cold in the upper atmosphere and it came down. Anyway, hypothesis testing is easily possible with visualizations. That's the same sort of visualization. We can do additional visualizations. Instead of dot plots or point plots, we can do ribbon plots. So in this one, we're going to do aesthetics. For the aesthetics, we're going to do the x is equal to the date. And then we're going to do a ribbon plot where the minimum is equal to minimum temperature and max is equal to max temperature. So this is going to give us a chart of temperature throughout the year. So our x is date and our y's are going to be a ribbon that varies between minimum and maximum temperature. So, like so. That's pretty interesting. And then we can add, as I mentioned, we can add units on top of that. So maybe we want to add an additional ribbon to it. So we can just copy, we can double what we're doing here. We can add an additional ribbon. We're going to say dew point. Say this, the second ribbon is dew point, that's going to be blue. So we can add multiple charts on top of each other. So yeah, like I mentioned, with ggplot, you have lots of discrete units. Oops. Sidebar. Lots of discrete units, lots of discrete types of charts that you can do on top of each other. And here you can do statistics, you can set the scales, you can set the colors, you can change coordinate systems, add labels. There's a nice amount of customizability that you can do. You can do GIS with coordinate maps. Yeah, that's ggplot. That's a visualization with tidyverse. I'll go ahead and stop there. That's all that I had prepared. Do we have any questions or comments? And I would like to preface by saying I'm not really an expert in R, so I might not have an immediate response to your question, but I'm happy to go try to look it up for you. Any questions on what we've done today or things you would like to know how to do? No? No questions? Okay. If there's no questions, we can go ahead and end there. Thank you for joining today. Hopefully you learned how to do some cleaning and visualization of data in R. Thank you. Have a good evening, everyone.